Hey guys, today I'm gonna start to talk about the statics. Today we start talk about the introduction to statics, and then eventually we will go to the other topics. So before we start talking about the statics and different methods we are using in the statics, there are some concepts that we have to get familiar with them. First of all, there are four different units, basically four units we are using in this course, and those units that we are using in this course, first of all, there's the time, then there is a length, then it's time, length, mass, and force. Among these four units, three of them are independent, so we choose three of them, and then we calculate the fourth one from the other three. So later on, when we get to the topics of the units and we talk about the units, we'll talk about more detail that how we are going to use these units and what's the different system of units we have. The other stuff that we need to know, one of that is particle. We talk about the particle a lot throughout the course, and the particle. So when I say the particle, basically we are talking about an object that we can concentrate its mass and ignore its dimension. For example, when we can do that, assume a planet that goes around the sun. One of the planets goes around the sun, and you look at the orbit it has and the size of the orbit it rotates around the sun, and the size of the planet. Most of the time, the size of the planet you just can ignore it compared to the past it goes around the sun. So we can assume it as a single point, and we concentrate all the mass at that single point. So that's going to be an object. The other word that we're probably talking a lot about that, and you're going to hear about that a lot throughout this course, is the rigid body. So what is rigid body? When we're talking about a rigid body, what actually means? The rigid body is the body that if we apply force on any part of that, on any member, we don't see any deformation. It's just simple form of that. So assume whatever, for example, most of the metals that we are looking at or steels, when you apply force on them, there's a very small deformation, or you can say there's no deformation. So in those cases, we consider them as a rigid body. And then we have concentrated form, and which is means that we have the force that applies on one single point. It's not the force that applies on the area. Later on, we will talk about the forces that distributed over the area or over the length. But for now, at the start, we only talk about the concentrated force which applied at one single point. These are the very basic concepts that we are going to talk about. That. Okay. Now that we said that, we're going to start talking about Newton laws. So let's say the very first law of the Newton. What it says that? It says that if the resultant force on an object is zero, it doesn't say that there is no force on the body. If the resultant is zero, if all the forces applied on an object cancels each other, what does it mean? It means that sigma f is zero. It's very hard to consider case that there is no force on an object, but there are lots of cases that can consider that forces cancel each other. So in any case, there's no forces or all the forces cancel each other. If there's sigma f is equal to zero, we'll say that the object tend to remain in whatever state it has. So it remains in it remains in its state. What does it mean? It means that if it's moving, it keeps moving with a constant velocity on the straight line. If it's at rest, it's going to stay at rest. So if everything is going to be zero. The second law of Newton says that no, if the force doesn't balance each other, if all the forces applied on the object does not cancel each other, what does it mean is sigma f is not zero. In this case, we have the forces and the forces doesn't cancel each other. In that case, we'll say that the object starts moving with the constant acceleration. So in other words, you have seen that the sigma f is ma, and m is the mass and a is the acceleration, and sigma f is the resultant force applying on that object. And the third one you're familiar with, on the third law of Newton, it says that for any if you have two objects here, for any action forces, there's a reaction forces. I'll make them equal. So if this is F, the other one's also F. So for any forces, then the reaction forces equal in the opposite direction. So these are the three laws of Newton, and probably we use the first one a lot. So with this, all what we want to do, we want to make sure if our object is at a state condition, it stay at that state condition, doesn't move, it just stay at rest, doesn't move and doesn't go anywhere. The other Newton laws that is important is the Newton gravitational attraction law, which what it says, sorry, there's a so it says that if there is a two objects with mass m1 and mass m2 at the distance of r, they are going to be attracted to each other with force F. So, for example, we have m1 sitting here and then m2 sitting here, and there's a r distance between them, so they are going to be attracted to each other. The capital G is the constant value, and as a result of that, if we simplify this equation, we will get to the very famous equation that again we are going to use it throughout this course, which is basically the weight is mass times gravity, mg. And later on I'm going to talk about that more for that particular equation. The units that we are going to use, it basically we have two main system of unit. The first one and the ones widely used is the SI unit, and the second is the US standard units that we will have with them. Again, if you remember, when I start talking about the units, we have said that we have for the units, we have four main units. So then they were time, there's a length, time, length, there's a mass, and there's a force. So if you look at them, let's have them. We have, I'll write it with green. So we have the SI unit, and then I'm going to write it with blue. Is the US standard or customary unit. So time for both of them are second. So for US unit is second, for SI is also in second. For the length, it's going to be, for the SI unit, it's going to be meter. And then for the US is foot. And then we come to the mass and force. So I'm gonna first talk about the SI unit. So the mass in the SI unit is a kilogram. And remember when I started talking about it, says that between these 4 units, 3 of them are kind of independent, and the fourth one calculated from those 3. So in the SI system, what we have is that we consider these 3 as independent, and then we calculate the force from those 3. So the force in the SI is Newton, and how we are going to get that Newton from that famous equation of from this equation. That's how we got the Newton. In the US system, it's a little bit different. So they consider the time and length and force to be independent. And for the force, it's pound. So these we have these 3 as independent, and then we calculate the mass from these 3. And the mass in the SI units, you probably already seen it, is slug. Again, we use the same equation to calculate the mass. This time it's just mass is force divided by acceleration. The same unit, the same equation, just we have these 3 and we calculate the mass. In the SI, we have these 3 and we calculate the forces. What is going to be important for us is that how we are going to use it in this equation. So if you look at this equation, we have, let's again put the SI in green. So the weight in the SI is in Newton, and the mass is in kilogram, and the gravity acceleration is meter per square second. In the SI unit, in the US unit, it's going to be, the weight is pound, and the mass is, like here, it's going to be in a slug, and G is foot per square second. And you know that you probably know that the G is 9.81 in the SI unit. So the value of the G is 9.81 in the SI unit, and it's 32.2 in the 32.2 in the US in the US customary unit. So that's how we need to know that when we are working later on in the course and we want to calculate the forces, we have to know how to use the consistent unit either in the SI or in the US unit. So these are the basics of what we have for the units and how we are going to use them. The very last topic I'm going to very quickly cover that for these units is that how we are going to convert the units from one system to another system. And One way of the easy way of doing that, you can do it in any way that you want, but an easy way of doing that is try to cancel the units in the way that we have it. For example, assume that we have the velocity is in 5 kilometer per hour and want to convert it to meter per second. So what we are going to do is that the velocity value is 5 and the units is kilometer per hour. So first we are handling the kilometer. So we are going to times it. So we want to cancel out the kilometer. So we put the kilometer here. So they will be cancelled out. And then we want it to be meter. So we put the meter here. Now, this parenthesis should be 1 because we are going to times it by 1. Otherwise, it's going to change the value. So we know that 1 kilometer is 1,000 meter. Now this is 1. That parenthesis is 1. Now we'll look at for the hour. So we want to cancel the hour. So put the hour here and want to have it in the second. So hour with hour cancel. Now we know that 1 hour, we want to make that parenthesis equal to 1. So it's a 1 hour is equal to 3,600 seconds. So this is 1, this is 1, and it's times by 1. So eventually you have 5 times 1,000 divided by 100, and whatever is the result is going to be in meter per second. You can do that with any other unit conversion, even if you want to convert in the metric, or if you want also to convert from metric to US or other vice versa. Can use exactly the same method here to cancel out the current unit and replace it with whatever unit we want, like what we have done here. And this is the very basics for what we need for the units.